So we're going to take a look at the 1.8, 1.9 homework. These are the word problems. Now remember, I asked you to actually solve the 1.8 problems even though they didn't ask you to in the book. So if you're checking answers, you're able to check answers this way. So number 19, Adam purchased a shirt at regular price. Later, when the shirts were on sale, he purchased 2 more at $2 off the regular price. He spent a total of $41 for the 3 shirts. So I began with my let statement. I let R equal the cost at regular price. And then just for clarity to make my own life easier, I also noted that R minus 2 is the cost on sale. So I'm able to set up my equation. He bought a single shirt at regular price, 2 shirts at the discounted price, and it cost him $41. From there, I can begin solving my equation. I distribute 2 to R into negative 2. I can combine my 2 like terms, 2R and R. I'm able to add 4 to both sides. And then to finish the problem, I divide by 3. So I find out that R is 15. Now, I took the time to write a separate line where I included my symbol for dollars. If you put that value right here, that'd be fine. There's no reason to rewrite it. Number 20, Lupe swims 2 fewer laps than Mary. If both added 7 laps to their daily swims, the sum of their laps would be 3 times as many as Mary now swims. So there's a lot going on in that one. Now, whether you choose to do like I did, I let L equal the number of laps swam by Lupe, which means L plus 2 is the number of laps swam by Mary. Or you could say M is the number of laps swam by Mary, making M minus 2 the number of laps swam by Lupe. Totally up to you. Now, just to keep things clear, these brackets aren't totally necessary, but I went ahead and set up L plus 7, so that represents Lupe's laps plus 7 inside a set of brackets, and then L plus 2 plus 7 inside a set of brackets to indicate Mary's laps, and then finally, finally, that would get me 3 times L plus 2, the total number of Mary's laps times 3. From there, I'm able to drop the bracket since I don't have any distribution to take care of. I'm just noticing I made a careless mistake, so I'm going to go through and fix that as we work on the problem. When I distribute the 3, I didn't multiply it by 2, so I need a 6. Now, from there, I'm able to combine my 2 like terms, so I end up with 2L. My other 2 like terms, I end up with 16. I subtract 3, so negative L plus 16 equals 6. I'm going to subtract 16 from both sides. That's going to get me negative 10. And so then I divide by my negative 1. Excuse me. I divide by my negative 1 and end up with L equaling 10. L plus 2 would now equal 12. Number 22. Paula's purse contains twice as many dimes as quarters and 3 fewer nickels than dimes. The total of these coins is $3.15. So I start off with Q is the number of coins. Q is the number of quarters. There's twice as many dimes as quarters, so 2 times Q would get me the number of dimes. And then there's 3 fewer nickels than dimes, so 2Q, the number of dimes, minus 3 would get me the number of nickels. Now, like we discussed in class, when I go to set up my equation, remember these variables just represent the number of coins, not the value of the coins. So I've got to multiply by the value of a quarter, the value of a dime, the value of a nickel. And then it totals at 315. So I take care of my distribution. I multiply my 0.1 times my 2Q, and I can start combining like terms. 0.25 plus 0.2 plus 0.1 gets me 0.55Q. I add 15 to both sides. 0.55Q equals 330. Divide by my 0.55, and that's going to get me 6 quarters. 6 times 2 gets me 12 dimes, and 12 minus 3 gets me 9 nickels. Now, 1.9, they do actually ask you to solve, so you should have been able to check your answers in the back. Let's start at number 12. Larry has an annual return of $200 and $213 from a $3,000 investment at simple interest, some at 5% and the rest at 8%. How much is invested at each rate? So I started with F is the amount invested at 5%, meaning that 3,000 minus F is the amount invested at 8%. There's no reason that you could not have started with your 8% investment and then done 3,000 minus that value, but I decided to start with the 5%. So I set up my equation, multiplying the percent, 0.05, times the amount invested, 0.08 times the amount invested, and I know that that has a return of $213. I distribute my 0.08. I'm able to combine my two like terms to get me negative 0.03f. I subtract 240 and finish by dividing by negative 0.03. So that tells me that f equals 900. 3,000 minus 900 is 2,100. And again, like that problem we saw in the last section, if you just went ahead and put your dollar symbol right there, rather than taking the time to rewrite as I did, that's fine with me. 14 is another coin problem. A collection of 30 coins worth $5.50 consists of nickels, dimes, and quarters. There are twice as many dimes as nickels. How many quarters are there? It seems like as you read that problem, they don't give us any information about the quarters, but they've given us enough information because they tell us how many coins there are total. So I start with n is the number of nickels. Since they told me there's twice as many dimes, that's an easy way to represent nickels and dimes. So n is the number of nickels, 2n is the number of dimes. And again, since they told us that there's 30 coins to begin with, if I subtract the number of nickels, I subtract the number of dimes, I'm going to know the number of quarters. And so I'm able to set up my equation. The value of a nickel times n, the value of a dime times 2n, the value of a quarter times 30 minus 3n. I do my distribution and my multiplication, and I'm able to start combining like terms. 0.05, 0.2, 0.75. If I add the 0.05 and the 0.2 and then subtract the 0.75, I get negative 0.5n. From there, I'm able to subtract my 7.5 from both sides, divide by 0.5, and I now know the n value. But notice this isn't what we were being asked for. We were being asked specifically for the number of quarters. So 30 minus n minus 2n gets me my 18 quarters. Now, if you gave all three values, that would be okay, but typically we would only want to answer the single question we've been asked. All right, and finally, 22. A grocer wants to mix peanuts and cashews to produce 20 pounds of mixed nuts worth $6.20. How many pounds of each kind of nut should she use if the peanuts cost $4.80 and the cashews cost $8? So very similar to that last coin problem, I can start with the P being the number of pounds of peanuts, or you could have started with cashews, totally up to you. But your next term would always be 20 minus the variable you've defined to represent the other value. So in my case, 20 minus P is the number of pounds of cashews. From there, I can set up how much it costs for a pound of peanuts, how much it costs for a pound of cashews, and then how much it's going to cost total, how much the mixture is going to cost per pound, times the number of pounds. So I take care of my distribution, I take care of my multiplication, leads to having two like terms, 480p and negative 8p, which leads to negative 3.2p. I can subtract my 160, divide by my negative 3.2, and now I know how many pounds of peanuts I have and how many pounds of cashews I have. Again, like I've shown in those other problems, if you include the units right at your first step and don't want to take the time to write a second line for the answer, that's fine with me. I just like to do that for a little bit of clarity. All right, this is wrapping up Chapter 1. We're going to have our quiz on Chapter 1 next week. Hope this helps. And again, if it doesn't, if you still have questions when we come back to class next week, feel free to ask.